Okay, this is where we left off on Monday. So if you are here for the first time this week, you missed Monday, make sure you look at the slides up to this point, and that you have the packet and that you're including all the notes into your packet. There's nothing to write down here. This is all already on your notes. But here we have the equation for figuring out either molarity or volume if we're dealing with solutions. Okay, and so a reminder from yesterday, molarity is an expression of concentration. So the higher the number of molarity, the more concentrated, excuse me, the more concentrated the solute is in the solution. So I had given you the example yesterday of Kool-Aid. If you have more Kool-Aid powder uh, dissolved into the water, you're going to have a higher concentration, therefore a higher molarity. If you have less powder, you have a less concentration, it's more dilute, and therefore a smaller number for your molarity. Okay, so that's kind of the basic idea. The definition of molarity is the number of moles, which is a count of the number of molecules or atoms or particles. So the number of moles per liter. Okay, so that's what molarity is. So if we are going to do this titration, which is we're performing a very tightly controlled neutralization reaction, we want to have equal numbers of hydrogen ions, which are the H plus ions, to the hydroxide ions, the OH ions. So equal amounts of both of those. All right. And we're going to be working and measuring with the volumes to figure all of this out. Okay. So M with the H plus is the molarity of the hydrogen ions. M with the OH minus, that's the molarity of the hydroxide ions. And then the two V values, the VH plus and the VOH, that's the volume of each of those, the volume of the hydroxide ions and the volume of the hydrogen ions. Okay, so if you know three of these, you can figure out the fourth one just like any other type of algebra problem. Okay, so we're just using basic algebra and some measurements to figure all of this out. Okay, I'm going to move on from here to the problems. All right, so we didn't do this yesterday. We're starting here today. So let's say we have a problem and we're doing a titration, and we have a titration of 40 milliliters of a nitric acid solution. The end point, which is where you see the color change, the end point is reached when 35 milliliters of a 0.0100 molar NaOH is added. Calculate the concentration of the nitric acid solution. So this is really similar to what we're going to do on Thursday. We're going to have, instead of nitric acid, we'll have hydrochloric acid. But otherwise, this is really similar. Okay. So what are we going to do with this? Okay, so we figure out what is the molarity of our acid, what's the volume of our acid, the molarity of our base, the volume of our base. Do we know all of these things? Well, we don't know the molarity of the acid. That's what we're going to calculate, but we do know the volume. So the VA was 40 milliliters. All right, that was the volume of the nitric acid. The molarity of the base, the MB, we got that from the problem, 0.100. And the volume of the base, that's what we measured in the titration, 35 milliliters. Okay, so we're just going to what they call plug and chug, which means you substitute the variables for the values that you have. And we have X as the molarity of the acid. And then we just algebra the heck out of this. And we get X equals 0.0875 molar. Okay, so what they're not showing you here is that you're multiplying the zero point 0.1 times the 35, and then you're dividing both sides by 40, and that gives you X equals 0.0875. Okay, so I'll leave this up for a little bit while you might be writing this down. If you need more time for that, you can always ask for the video to be paused, or you can always take pictures. Also, this is in the slides. You can open up Google Classroom, open up the slides, get this out of there. Okay, so minor pause while, if you need to take a picture. I'm going to move on in 10 seconds. All right, moving on to problem number 2. So, titration problem number 2. What is the concentration of a hydrochloric acid solution if 50 milliliters of a 0.250 molar potassium hydroxide solution are needed to neutralize 20 milliliters of the hydrochloric acid solution of unknown concentration? Okay, so again, very similar to what we're doing on Thursday. We'll be using hydrochloric acid. You won't know the concentration, but we are going to titrate with sodium hydroxide. All right. So you'll know the molarity of the sodium hydroxide. You'll be given a specific volume of hydrochloric acid. And then you're going to measure the sodium hydroxide put into the hydrochloric acid to neutralize it. Okay. So what do we know from here? It's all in green. All right. So we know we have 50 milliliters of hydrochloric acid. We know we have a potassium hydroxide solution of a 0.25 molar concentration. And in this problem, they have titrated, and it took 20 milliliters to neutralize the hydrochloric acid solution. So that was when the color change happened in this problem. Okay, and then what's in yellow is what we are trying to find out, the concentration of the acid solution. Okay, so again, here's what we would write out. So Ma is the molarity of the acid. We don't know that. We're going to call that X. Va is the volume of the acid, and that was already given to us, 20 milliliters. And then the molarity of the base, we already know that. That was given to us. There's probably a bottle, and it says 0.25 on it. So we know the molarity. And then the volume of the base is 50 milliliters. Let me just check something. I'm going to go back. Okay, yeah. All right. So you should write that down. You should always write down what you know from a problem, so you can see it all laid out. And then this makes it very clear. We're going to use MV equals MV, right? MAVA equals MBVB. And I'm going to switch the slide in about 10 seconds if you need more time. Make sure you take a picture, or like I said, use the slides in Google Classroom. And off we go. Like it says, plug and chug. We're going to algebra the heck out of this. So we plug in X for MA, and then the 20 milliliters for VA equals MB, the molarity, 0.25, and then VB, 50 milliliters. Right, multiply 0.25 times 50, and then you divide both sides by 20. You get X equals 0.625 molar. Okay, so I'll let you sit on this for a little bit. I'll change the slide in about 20 seconds. Okay, and also it's in Google Classroom. If you would rather look at the slides, you can always open that up, or if the slide changes and you miss something. Okay, it's always there. All right, we're going to switch to the next slide. And I think, that's it. So let me get out of here because now we're going to go to the next page. And this is, where is it here? We're going to talk about acid-base titration. Oops, that's not what I want to do. I want to go here. Sorry. Little technological difficulty there. Okay, so the next page of your notes is specifically about titration. We had been talking about molarity and neutralization, and then the titration problem was the mathematics that goes with it. So how do we actually figure out the endpoint? Like, where do we get that measurement? How are we going to physically do that on Thursday? That's what this is about. Okay, so if you have this picture in your notes, this is going to be our setup on Thursday, except for, I don't know if you can see my mouse, but it has like this little flea here, this little spinner. and like this little, we used to call them stir bar. I guess they call them fleas. And then they have um, a stirring platform here that has a magnet, and it actually makes, or I think the magnet's in the stir bar, but it actually will stir for you. We're not that fancy, so you're not going to have that, but we will have the flask. Okay, so a conical Erlenmeyer flask, and then what you see here, this tube that has the graduated um, indicators on that show volume, that's called the burette. You'll have that too. So you'll have the burette, you'll have the conical Erlenmeyer flask, and then you will have the stand. The stand is there to hold the burette. Okay, so we're actually going to set this up on Wednesday and do like a cleaning of the burettes, and that'll give us some practice on how to use the burettes and how to use the flasks. We need to use them safely because it's all glass, and also the burettes are a little bit delicate. So we'll talk about the proper use of these burettes on Wednesday. Okay, and then there's a little reminder here how to read the volume. There will be a meniscus, which is the curved interface between the liquid and the atmosphere, and you always want to read the bottom of the meniscus. So you want to put your eyeball kind of at level of the meniscus, so that's where you read. You don't want to read the top of the meniscus. You want to read the bottom. Okay. All right, so what is titration? It is a method of analysis that allows you to determine the precise endpoint of a reaction and therefore the precise quantity of reactant in the titration flask. Okay, so what that means is we're going to be putting um, the unknown acid into the flask. We're going to be putting the sodium hydroxide of a known molarity, so we'll know the concentration. I'll tell you it of the sodium hydroxide, and then we're going to slowly stream in or drip in, depending on how where we are in the titration. We'll be slowly putting in the sodium hydroxide into the acid, and a neutralization reaction will begin. Okay. And what we're going to look for is the color change. Right when the color changes, that is going to be our endpoint. All right. And at that point, we know as close as we can get it with our equipment, we have an equal number of hydrogen ions and hydroxide ions. Those two will be equal. Okay. So it says a burette is used to deliver the second reactant to the flask. All right. So we just talked about that. And an indicator or pH meter is used to detect the endpoint of the reaction. So we are going to be using the indicator. Like I said, we're looking for a color change. All right. So what you'll be doing is as you're streaming in or dripping in the sodium hydroxide into the acid, you'll be since we don't have stirrers, you are going to be the stirrer. You're going to be taking the flask and really gently moving it side by side, allowing the liquid to swirl around, and that's going to evenly distribute the sodium hydroxide into the hydrochloric acid. Okay, I'm going to switch the slide in about 10 seconds. If you need more time with that, then you need to just take a picture or use Google Classroom. All right, switching the slide. So doing a titration, you can see the person's wearing gloves, will be wearing gloves, and this person's manipulating the the little knob that opens and closes the burette. Okay, so what we're going to do tomorrow on Wednesday is we're going to prepare the burette. Right, that gives us time to get to know the equipment and also wash it out, make sure it's all clean. So we're going to wash it out with soap and water, and then rinse with tap water, and then also distilled water. Right? Why we need to use distilled water is because there are various ions in tap water that we don't want to be interfering with our experiment. Okay. And then we'll be rinsing with the titrant solution. So we're going to run and we'll probably do that one. Yeah, we'll do that one on Thursday. We'll run the titrant through on Thursday. So Wednesday, we'll just wash with soap and water, rinse with tap water, rinse with distilled water. And then on Thursday, we'll do one more rinse with distilled water and then do the rinse with the titrant. Okay, and we'll be checking for air bubbles and leaks before proceeding with the titration. So if you see anything amiss with your burette, like something looks leaky, bubbles don't go away, then you let me know. We can give you a different one. Okay, and then be sure the tip of the burette is filled, and then you never dispense all the way down to the end of the burette. You don't want to completely uh, empty out your burette and still not reach your end point. So the way I've got it figured, that shouldn't happen. I'll do a test run just to make sure before you guys get it. But you never want to have such a weak solution of your titrant that um, it's not going to equalize with your acid or whatever your unknown is before it empties out the burette. Okay. All right, I'm going to switch the slide in about 20 seconds, so make sure you've got this. All right, switching the slide. Okay, so when you fill your burette, um, and actually I'll be helping you guys with this because this is a little bit tricky. They're really tall, and you have to use a funnel, and it's really easy to spill. So I'm going to help you with this one. Once we have the sodium hydroxide in your burette, you need to take an initial volume and record it. All right, so wherever it is, remember you're looking at the bottom of the meniscus for this. Um, and then before beginning a titration, you should always calculate the expected endpoint volume. That way, you know, like, okay, we have enough volume in the in the burette um, in order to correctly titrate and um, reach the endpoint without running out of our titrant. Okay, so if you put in, so you fill up, say, half your burette, and you're like, okay, this should be enough, and then you reach the end and you're like, whoops, that wasn't enough, right? So it's always good to do like a guesstimate of how much volume you're going to need before you start to make sure you have at least that much, and you should always have a little bit more. Oops, let me put that back and just say, yeah, if you need to catch up, take a picture. I'll change this in about 10 seconds here. Okay, now changing it to the next slide. Okay, and then you prepare the solution to be analyzed by placing it in a clean Erlenmeyer flask. Um, so uh, that might be a little bit tricky. We need to clean our flasks, but so we're going to get some clean flasks or beakers. If we don't have enough flasks, we'll get some beakers and take your unknown solution and take a specific volume. So we want to measure the volume we're putting in um, and put it into the flask or the beaker. And I will be giving you a solution so you won't need to worry about it being solid. But let's say you're doing this on your own in a lab, you would need to make sure your solid is completely dissolved. You don't want to see little bits of stuff floating around. Okay, I'm going to change the slide in about 10 seconds. So make sure you've got everything written down or take a picture. Okay, moving on. Oh, I forgot this part. And then add an indicator. So our indicator that we're going to use on Thursday is phenolphthalein, and this will be a pink color. So we'll be looking at a change either from pink to clear or clear to pink. We'll go over that. Okay. And then use the burette to deliver a stream of the titrant to within a couple of milliliters of your expected endpoint. All right. So you see the tip of the burette is inside the flask a little bit. You need to be really careful at this point because the tip of the burette is the most delicate part. It's thin. It's kind of delicate glass, and if you bang it against the flask, it's going to break. And we just got all new burettes about 2 or 3 years ago, and they're, as far as I know, they're all still good. So we want to make sure we're taking care of them. We only have like 10 burettes for the whole campus, so we got to share this with other teachers in other classes. Okay, so you'll see an indicator color change when the titrant hits the solution in the flask. So you can see in the picture there, the solution is clear in the flask, but you see a little bit of pink there. So you'll see like, oh, like it's turning pink. It must be almost done. But as soon as you stir it or swish it around a little bit, it disappears. That just means in that one little area, yeah, you got that pH change that is indicated by the color. But once you distribute it through the whole flask, oh, it's not there yet. Or, it's not quite there throughout the whole solution. All right. So the idea is you want to hit that point where it turns color throughout the whole solution. And then uh, right before that is where you have the neutral point. So you don't want to tip over that too far. Okay, whoops. Let me leave it on here for about 10 more seconds. Okay, and moving on. Okay, so approach the endpoint slowly, right? So as you start seeing more and more of the color change, you want to start backing off the stream of sodium hydroxide and go more like drip by drip. Okay, not too much, not too slow because, we only have an hour to get this done, but, kind of back off and slow down. And if you need to stop and just, swish the flask around, do that. Okay, because you want it really stop right when it turns pink and maybe even right before that. Okay, so it says use a wash bottle to rinse the sides of the flask to make sure all the titrant is mixed. We're not going to do that. Yeah. Uh, I've never done that, so we're not going to do that part. And then make sure you know what the endpoint should look like. Okay. So we'll go over that because I just want to double check. I'm pretty sure we're going to go from clear to pink. If it's not from clear to pink, it's pink to clear, but I'm pretty sure it's clear to pink. So your endpoint should look like that color change just barely done. Okay. You don't want to go like a full dark color. If we're going from clear to pink, we want to go just to where it barely turns pink. Okay. And yeah, so that's the phenolphthalein that we're using. The first permanent pale pink. Okay. And then the pale pink fades in about 10 to 20 minutes, which we're probably not even going to see that because by the time we get everything set up and do like a quick review and then you guys do your titration, we're probably going to be about, you know, 10 to 20 minutes right before the end of class and we need to start cleaning up anyway. So you won't see the fading, but that's okay. We don't need that. All we need to know is where does it turn that pale pink color. Oh, let me leave it on here for about 10 more seconds in case anybody needs pictures. All right, and moving on. Okay, if you think you might have reached the end point, you can record the volume and then add another partial drop. So you can take a look like, oh, okay, here's the volume that we're at right now. It's at 12.5 milliliters. Maybe that's the end point. You can like write it down. You can always change it later. Okay, and then add another like small drop, and then it's you might find this what you see here like the whole solution's gone pink. At that point, you're done, and I would use that endpoint or sorry the volume that you took right before you hit that last drop, rather than the one after the last drop. Okay, because really you were at neutral right before that last drop. Okay, so if the flask looks like this, you've gone too far, but just barely. So it, take some volume points as you're getting close. And then if you feel like, oh, I went a little bit too far, use not the volume you're at right then, but the one you took just before that. And do I have one more? Nope, this is it. That's the end of the notes. So we are done. We're done with the notes. Now, what we're doing for the rest of the week is, like I said, Wednesday, we're going to prep for the lab. We'll actually take out the burettes, get them all set up, wash them out and everything. And then Thursday, we're going to actually do the titration. And then if we need to finish anything on Friday, it's probably just some questions and some calculations. We'll be done for the week. We got this. All right. For the rest of class, what you need to do is go into Google Classroom, make sure you're caught up with all the notes. So all your notes should be done. And if you haven't done the reading assignment that's online, you can do that, answer the questions. And please do the Ed puzzle before Thursday. I know it's not technically due till Friday, but the Ed puzzle is showing you how to do a titration. Okay, so it's good prep for Thursday. And if you need anything, to email me, or I will be back tomorrow. All right. So thank you so much.